Good morning, students. Welcome to today's session. We will begin with today's session. Let me present the screen of welcome you all to Lecture 7 of Signals and Systems. So, today's topic that we are covering are energy and power signal. And we have solved a number of examples. Two more examples I'll be solving in this. And followed by we have a new topic for today's session, that is basic operations that are performed on signals. Okay, so these two topics will be covering in this session. Let me begin with the next problem. Before that, I summarize what we covered in the previous class. In the previous class we could solve around 10 problems, 10 to 12 problems on energy and power signal. There was one doubt asked by one of the student, that what is the difference between deterministic signal and periodic signal? So, all periodic signals are deterministic signals. All periodic signals are deterministic signals. But all deterministic signals are not periodic signals. Because let it be periodic signals operation or its change in the value are predictable. So hence it is deterministic signals because there is no uncertainty. Whereas there is some exponential curve going on, which is not periodic signal, but you know that it is an exponential curve. You know what happens, what is going to come in the very next time or very next sample. So that is not a periodic signal, but it is a deterministic signal. Okay, so hence I put before you the statement once again: all periodic signals are deterministic signals, whereas all deterministic signals are not periodic signals. So this was the doubt asked by one of the students in YouTube comment, and that's why I wanted to tell orally before you. So I hope I cleared your doubt. So with this, we are starting up with the next problem, so which I wanted to give it as an assignment, but still I want to solve it here because this has been comparatively a different kind than what we had solved in the earlier class. There is a trapezoidal pulse x of t defined by as given in the mathematical model. For this mathematical model, I have drawn the waveform. Actually, there was no waveform given. There was only mathematical model given. So any vice versa, you should be able to do it. Okay, we have already understood it. For example, phi minus t. In what range? When t is having value between 4 to 5. Let me substitute 4. 4 is here. 4 is here. So if I substitute 4, what would be the answer? 5 minus 4 is 1, so amplitude is 1. So it is still in the range when my value of t is 5. So when I substitute value of t as 5, 5 minus 5 is 0, so 0. So this is a continuous time signal, so linearly varying curve. So hence I'll draw it in the linearly decreasing curve, negative slope. Similarly, 1, it will stay at 1 in the range minus 4 to plus 4. Minus 4 to plus 4, it is staying in the range of 1. So hence you just keep it constant, the amplitude being 1. So in minus 4 to minus 5 range, the t plus 5 is a signal behavior. So you substitute minus 5 first. Minus 5 plus 5 is 0. So that's why I got it as 0 here at minus 5. When you substitute minus 4, minus 4 plus 5, when you are at minus 4 plus 5 is 1. So again 1. So it is the increasing curve with slope 1. So this is how you need to draw the diagram when the mathematical model is given, and vice versa using the straight line equation when 2 points are given. For example, if I want to find out this equation, so how to do it? So mark this point, mark this point. You can read this point as x-axis minus 5, y-axis 0, minus 5 comma 0. This as x-axis minus 4, y-axis 1, minus 4 comma 1. 2 points you have. Generate the equation of a straight line, so that equation will resemble t plus 5. Similarly for this one, 5 minus t. Okay, and when amplitude is constant, there's no much hindrance for drawing a diagram. You can directly draw a constant line. Okay, so this is how you need to write a mathematical model from the waveform which we have already seen. So let us go further and solve this and check what will be the answer. I have given the answer here thinking to give it as an assignment, but later on what I felt is let me solve it for you. So here, so energy, it has been mentioned that it is an energy signal. Okay, if at all it is not mentioned, by looking at it, at the signal itself, I can predict, because it is not a periodic signal. It is not a periodic signal, it is a aperiodic signal. When it is a aperiodic signal, what you need to find, you should find a energy signal itself. Aperiodic means energy itself. So that conclusion we make before we proceed, as it is already given, so we'll directly proceed with the solution. So I apply the energy formula. So you know that energy formula is minus infinity to plus infinity integration, because it is a continuous time signal, x of t square dt. So now we will apply the same thing for the given problem. So here, integration. So I have different behavior of the signal at different time slots. So hence what I do is I split it in terms of three parts: minus 5 to minus 4 range, or else let me start from here, 4 to 5 range, minus 4 to 4, minus 5 to 4, minus 4. So these three ranges I'll be separately taking here. So from 4 to 5, x of t is 4 to 5, x of t is 5 minus t whole square. Okay, plus from minus 4 to 4 range, your amplitude is, signal is 1 dt. I forgot to write dt here, let me write. Then plus, next range is minus 5 to minus 4. So here your signal behavior is t plus 5 whole square dt. So this is the equation from the given trapezoidal pulse. Now we'll proceed carefully. So as the squaring option, square is there, 5 minus t whole square. Let me take it in this fashion. Lower limit is 5, higher limit is 5, 4 and 5. So 5 square, 25, plus t square minus 2 5s are 10 t into the bracket dt, plus, so this one is straightforward. Integration of 1 dt is t, the limits I'm writing, and here again I have to apply a plus b whole square formula. Lower limit is minus 4, higher limit is, lower limit is minus 5, higher limit is minus 4. So t square plus 25 plus 10 dt, 10t into dt. So this is a integration application. So now I integrate it. 25 integration 25, I take common, take out, and 1 dt is t, plus t square. So integration, after integration it is t cube by 3 minus 10 t square divided by 2. So apply the limits 4 and 5. Then here I'll apply the limits. T, we should be substituted by 4 first, minus, substitute the next term, that is minus of minus 4, plus, so t squares integration is t cube by 3. So 25, when it is integrated, 25t plus 10t, 10t square by 2. So lower limit, higher limit. Okay, so now we have to proceed with the value given. So so this one I'll take it in the next slide. So this is a question continued. So I have written here in order to save the time, because I should go on writing each and individual step, that's why. So 25 as it is, so there was no t there. So here 125 by 3, because I'll show it, sorry. So here when I substitute t with 5, you will get 5 cube. 5 cube is 125. Okay, similarly t square, so t square is 5 square 25, 250 by 2, 250 by 2, I can cancel it, later on I'll do it, 250 by 2. Similarly here, so 4, when I substitute 4, 25 into 4 is 25, 4 is a 100. So 25 t cube, 4 cube is 64 by 3. 4 square is 16, 16 into 10 is 160 by 2. All those things I'm writing here. Okay, so this is 125. So because it is Um, as I had said 25t, it was 25 5s are 125. Same here. When I substitute 4, this I get. So this one 4 minus of minus 4, that is 4 plus 4, 8 I got. So this I get substituting minus 4 in place of t. In place of t I should substitute minus 4. In place of t I should substitute minus 5. I just mark it here. This I got by substituting t with minus 5. This I got by substituting t with minus 4. This I got by substituting t with just 4. This I got substituting t with 5. You can check it. So this is range of minus 4 to plus 4. So when I simplify it, so you can cancel it out, 125 here and 125 here, minus 125, minus 125, cancel it. So whatever I have ticked it, here ticked it, minus 100, minus 100, it becomes minus 200. This I have marked here, 125 by 3, 125 by 3, that is 250 by 3. And then dot, wherever I have put dot, 80 plus 8, 88, 88 plus again 8, 80, 168. Then whatever is left out, if I just add it, so I get it as minus 128 divided by 3, that is minus 64 by 3 and minus 64 by 3, minus 128 by 3. Okay, so I use a calculator for this, 83.33, 42.66. So when I use a calculator, I would get the answer as 8.66 joules. Okay, so I hope there are no doubts in this problem. So let me quickly go to the next problem, and the last problem of energy and power signal. This has been last problem. Read the question carefully. Determine the total energy of a raised cosine pulse. What is the meaning of raised cosine pulse? Raised cosine pulse meaning is given here. This is a raised cosine pulse. Okay, so this equation, whatever I have written, is known as raised cosine pulse. Okay, remember this. So in your exam, we might not mention the mathematical model as well as a graph. So what you have to do is you should remember this. Raised cosine pulse means this is equation. This equation behavior is in this way. Okay, that's what you need to remember. So it is defined as x of t is equal to 1 by 2 cos omega t plus 1 in the range minus pi by omega till pi by omega, 0 otherwise, 0 otherwise. So it exists only in the range minus pi by omega till plus pi by omega. Okay, so I have drawn the graph, I have given you the equation, I have told you what's the meaning of raised cosine pulse. Please remember this. Okay, so let me solve it. Simple. So they have already mentioned it as energy, means it is a aperiodic signal. So raised cosine pulse is aperiodic signal. Cosine pulse is periodic. Raised cosine pulse is aperiodic because it does not exist beyond this. Post pi by omega, for any value of t, your signal is 0. Previous to minus pi omega, for any value of t, your x of t is 0. That's why it is a periodic signal. It's a periodic signal. People will confuse if it is given in the 1 mark question. Raised cosine pulse is periodic or aperiodic. So people will confuse thinking that cosine is a periodic, so they'll take it as periodic, but it is a periodic signal. Okay, since here we are computing energy signal. So energy should be computed from minus infinity to infinity, x of t whole square dt. So here if I apply this energy formula, so the integration changes its limit from minus pi by omega till plus pi by omega, because post of it and pre of it, it is 0. So that's why I don't take it into account. In this range, I have given you the behavior of the signal, half cos omega t plus 1. I have to square it because it is energy. I have to square it, dt. So now let me solve it. So 1 by 2 square, 1 by 2 square, if I take it outside, what do I get? I get as 1 by 4. So let me write it at pi by omega. So 1 by 4 cos omega t plus 1 whole square dt. So this is what you need to write. And then let me take this 1 by 4 outside. So write it. So what do you get? Cos omega t, a plus b whole square. Cos square omega t plus 1 plus 2 cos omega t. Students, if you are aware of the making it simplified, I have a way to simplify it. Let me change the color and tell you. So equivalent of writing it in order to simplify ourselves. I can see here. Lower limit is also same, higher limit is also same, only it is varying in terms of sign. In this scenario, what you can do is, whenever the limits are same, for example, minus a plus a x of t dt. If this is a scenario, then it is equivalent. It is equivalent if I write it in this fashion. 0 to a, 0 to a x of t dt 1 by 2. Okay, it's equivalent if I write it in this fashion. It's in order to simplify. Okay, it's a rule of integration. It's not nothing to do with signals and systems. It's a rule of calculus. Okay, so let me apply that in order to simplify my work. Okay, so I think it's not 1 by 2, it's into 2. It's into 2. So into 2, because you will get in the same fashion. It's into 2 because it's twice the curve. So I'm taking the average of this part. I'm computing the average of this part. I'm multiplying into 2. That's it. What is the meaning of integration in physics? In terms of physical meaning of integration means what? Physical meaning of integration is trying to find out area under the curve. You know the physical meaning of addition, right? If you know, on one hand you have two apples, on the other hand you have three more apples. If I ask you, like, how many apples do you have in total, you add 2 plus 3 and you have 5 apples. This is a physical meaning, right? Subtraction physical meaning you understand. Multiplication physical meaning you understand. But have you ever tried to understand the physical meaning of differentiation and integration? Even that is a simple mathematics, like your addition and subtraction. Okay, if you have not understood the physical meaning of integration and differentiation, please understand at this level itself. Differentiation, I'll take it later. Integration's physical meaning is, it's like trying out or finding out the area under the curve, any curve that is given. If you want to try the area under this curve, if it was square, it was easy for me because I have a standard formula. If it was rectangle, I know there is a standard formula. But if there are some different looking, like odd shaped waveforms, then to find the area under the curve is not easy. So hence we go for integration. So if I ask you to find the area, okay, of whole of this, what I do is I find area of only this part. Only this part I'll find the area, and I'll multiply it by 2 because I know that it is symmetric. That's what I'm doing here. It's like finding the area of whole of this. Whole of this. It's like finding the area of only this part. And I'm multiplying into 2 because it result in same answer. So 1 by 4, I apply this one. Into 2, into 2, I apply integration from 0 to pi by omega. I write the same thing. Cos square omega t plus 1 plus 2 cos omega t dt. So this made my equation very simple. Very simple now. So now I apply the integration. So this becomes 1 by 2, 1 by 2. So cos square omega t, directly I cannot apply the integration. So what I have to do? Cos square theta is cos 2 theta. In place of theta, I am having omega t. So cos 2 omega t plus 1 divided by 2. Right? This is how you need to apply integration for this. Plus, what is the integration of 1? It is just t. I am writing t. Okay? Then it's integrated already. Pi by omega 0 plus 2, I take it outside. What is the integration of cos omega t? It's sine omega t divided by omega. I apply the limits. So this is not yet integrated. I'll be integrating it in the very next slide. Next slide is continued. Please look at it. Second term is t. It's already simplified. Third term is 2 sine omega t. So if I apply the limits here, pi by omega minus 0. Okay. So here only pi by omega left will be remaining here. Sine omega t. So in place of t, if I substitute pi by omega, omega cancels, sine pi. What is sine pi? What is sine pi? Sine pi is sine 0 is 0. Sine pi is also 0, right? So this term goes to 0 when I substitute the higher limit, upper limit. When I substitute lower limit, sine 0 is 0. So whole this term goes to 0. Okay. So let us do this and then proceed. I'll go take the next slide. Okay. So this is equal to, energy is equal to half, because half is there. I'm doing this. So integration. So integration. There was one more 1 by 2. I'll take that outside. 1 by 2 here. I'll take it outside. So now I write the integration. Integration of cos 2 omega t is sine 2 omega t divided by 2 omega. That's the integration of cos 2 omega t. Plus 1 is there. 1 dt. Integration is again t. So apply the limits. Limits are pi by omega 0. Okay. Pi by omega 0. And here I take one more step. I extend one more step. Pi by omega 0 plus 2 sine omega t divided by omega pi by omega 0. So this is a repetition of the step. Let it be. So now we will have a clear idea about it. 1 by 2. This is 1 by 2. Apply the limits now. Upper limit pi by omega. If I substitute pi here, pi by omega here, omega cancels. It comes out to be 2 pi. Sine 2 pi is 0. So sine 2 pi is 0. It's gone. So 0 if you supply, that also gives you 0. So what you're supposed to do is, in place of t, apply the limits. You will get it as pi by omega minus 0. So I don't write minus 0. Plus, so here I have got pi by omega. So this whole goes to 0 as discussed earlier. Okay. So this gives you, so 1 by 2, this is as good as pi by 2 omega plus pi by omega. This is equal to 1 by 2 pi by omega. I'll take common. I get it as 1 by 2 plus 1. So this gives you pi by 2 omega 3 by 2, right? So 1 by 2 plus 1 is 3 by 2. So this gives you 3 pi by 4 omega. So this is your energy in terms of joules. Okay. So this completes the problem solving on energy and power signal. So then we shall move on to the next session, next topic. The next topic being of this lecture 7, basic operations of the signal, or basic operations performed on the signal. So this is the next topic, and I'm again telling you, very interesting topic. It's like puzzle solving, and you find the related questions in your gate exams also. Okay, operations performed on signals. Fine. There are two kinds here. The first one is operations performed on dependent variables. Which is a dependent variable? I have two things now. One is x of t, the other is t. So time is not dependent on anybody. So right, this is independent variable. Remember this. What about x of t? Amplitude. Amplitude is always dependent on time. So it is a dependent variable. Okay. So time dependent and independent. So first we will discuss on operations performed on dependent variable. So next is operations performed on independent variable. Okay, so here the operations performed on dependent variable, we have 5 different operations that we are performing. First being amplitude scaling, addition, multiplication, differentiation, and integration. Next being operations performed on independent variable. It's time scaling, reflection and folding, time shift, time shifting, precedence rule for time shifting and time scaling. So this is being the last one being very important and confusing one. For that you should uh, concentrate well. Okay, so let me proceed. So here operations performed on dependent variable x of t, amplitude scaling. Amplitude scaling, let me write it. So y of t is equal to c into x of t, c into x of t for all t. Okay, so here c is scaling factor, c is scaling factor. Okay, so if I try to write it in terms of discrete time, y of n is c into x of n for all n, where say c is a scaling factor. The meaning is amplitude scaling means think that I have a signal. Think that I have a signal like this. This signal. Amplitude is 1 from minus t to plus t. Okay. So if I want to scale it up, if I want to increase the amplitude by 2 times, then what I do is I write it as 2 times of x of t. So what I get is I get it like this. Say minus t to plus t, the amplitude becomes doubled. Amplitude becomes 2. So this is called amplitude scaling. Okay. So addition. So addition is y of t is equal to x1 of t plus x2 of t. So similarly, if I want to write y of n, x1 of n plus x2 of n. These are the examples for addition. Let me take an example here. Think that you have two audio. For example, I am recording a song. So in that case, what we do is we'll be having a y signal. Let me call y signal as x1 of t, and I want to add a background music to it. Background music being x2 of t. So when I add these two things, I'll get y of t, which I call it as song output. Fine. So mixing of audio signals are an example for addition of amplitude. Okay. So this is how we add it, audio mixer. Next comes multiplication. So multiplication is performed in this way. Y of t is equal to x1 of t into x2 of t. If it is in digital discrete mode, y of n x1 of n into x2 of n. So here the best example is, in general we call it as a modulated wave. I think in your basic electronics you might have learned something like amplitude modulation, frequency modulation and all. This modulated wave will be multiplied with a carrier wave. Modulated wave is a message signal. Carrier wave is the one which carries. So when I add these two things, when I multiply these two things, if I call this as x1 of t, this as x2 of t, when I multiply these two things, I'll get a final modulated wave, right? So that we call it as output signal, that we call it as y of t, multiplication. The multiplication example is modulation. Next comes differentiation. So differentiation goes like this. Y of t is equal to d by dt of x of t. This is the differentiation. What is the meaning, physical meaning of differentiation? The physical meaning of differentiation goes like this. For the change happened in time, what is the change happening in amplitude? For example, think that I have some exponential or linearly exponential signal like this. Okay, this is a time signal. This is a amplitude signal, amplitude axis x of t. So I locate 2 points here. let me call it as T1, let me call this as T2. From changing the value from T1 to T2, from here to here, what is the change happening in the amplitude? That's the meaning of differentiation. For example, I mark it here. I mark it here. So this is a change happened at T2. This is a change happened at T1. That I note it here. This I call it as X1 and this I call it as X2. So the difference I call it as delta X or dx. So change happened from T1 to T2 at a time axis result in what amount of change in the amplitude, right? So this gives you the physical meaning of differentiation. For example, take an example of you being writing the exam of signals and system before training happens or before you taking up the class and after taking up the class. There will be variation in the marks scored by you, right? So that I can call it as differentiation. Okay, so differentiation, what is the access I have taken before taking the class and after taking the class? Again time here. So what is the amount of change in the marks that has happened? So that gives you the differentiation value. Okay, so to give the technical example for it is a inductor. You've come across inductor component. So inductor's voltage is measured as inductance d by dt of current. So this is a formula for inductor's voltage calculation. This is an example of differentiation. Means why I have to learn this thing in signals? Y of t is equal to d by dt of x of t, because somewhere in electronics I can apply, right? I can apply because in electronics such formulas are present. Hence I am learning it in signals and system. So try to relate mathematics with electronics from here on. So now coming to integration. So integration, and of course, differentiation and integration in discrete domain. In discrete domain, it does not exist. Okay, so I'll come to that point in later stage. Okay, so right now you just have some idea. Differentiation and integration is applied only for CT signal, continuous time signals. Okay, so this is y of t integration from minus infinity till t x of tau d tau. So this is an integration formula where tau is integration variable. Integration variable. Okay, so here I quote an example. I quote, take it capacitor. So how to find the capacitor's voltage? So capacitor's voltage is found by the formula 1 by C integration from minus infinity till t I to d2. So this is the meaning of the integration. Integration means how much voltage got stored in the capacitor is calculated by the current that you have supplied for the given amount of time. Think that you have supplied this much current. So I have to find the area under this curve. With this area under the curve calculation, I can find out what is the amount of voltage that got stored in the capacitor. Okay, this is one example. In electronics, this exists. Hence, in signals, we are learning integration. I'm trying to relate. So these all are the operations performed on dependent variables. Okay, so let me take one or two examples before I conclude this session. So in discrete time signal, as soon as I write x of n, you should come to the conclusion that it is a discrete time. So the signals are given as this is how it is given, 0 otherwise. N is equal to 0 and for n any value greater than 1 either in the negative direction or positive direction. This is how it is given. Okay, so what is the question is find the composite signal. Find the composite signal y of t. Composite signal means Composite signal means like this. Y of, so not t, y of n. Y of n, it is given actually in the question. Y of n, x of n plus x of minus n. This is what you need to find. This is one example for addition. So if I want to try to add it, the solution goes like this. So x of 1 is 1, x of minus 1 being minus 1. So for any other value of n, your value is 0. Any other value of n, your value is 0. So hence, if I want to multiply, not multiply, add x, y of n, so this is x of n 1 plus x of minus n is minus 1. Both cancels and you get a 0. It's a 0 signal for all n. This is 0 signal for all n. If I want to try write it in terms of signal, so at 0, 1 and minus 1, your n value is 1 here and your amplitude is 1. Your n value is minus 1, your amplitude is minus 1. Okay, so it is 0. Everywhere it is 0. So if I just, this is x of n. If I take x of minus n, take its antisymmetry. So if I try to write it, the values get interchanged, antisymmetrical. Okay, so this comes over here, this comes over here. So if I try to add these things, 1 plus of minus 1, it goes to 0. This is minus 1 plus of 1 cancels, again go to 0. So always when you add these two signals, your y of signal will be always 0. Okay, so composite signal will always give you 0 for this given problem. I hope it is clear. Second one, x of n is equal to 1 for n is equal to minus 1 and n is equal to 1, and n equal to 0 and n greater than 1. So the meaning of this is either a negative or positive. If it is greater, value is greater than 1, it goes to 0. Almost in the same way, but slightly change. So for n equal to 0, 1 and minus 1, your amplitude is 1 itself. 1 itself. Rest everywhere it is 0. Rest everywhere it is 0. Now if I ask you to find out the composite signal, it is very simple. Amplitude is 1 for x of n also, x of minus n also it is 1, x of plus n also it is 1. So when you add it, you will get it as 2. You will get it as 2. Very simple. Okay, this is example for addition. The last example of this session. So I have x of t, x1 of t given as x1 of t given as a rectangular pulse 1. This is rectangular. Okay, please bear with me for my diagram. This is t plus, I have to add it, it's an addition again, add it with x2 of t. So here it is given as 1, 2. Okay, so I need to add these two signals. If I add these two signals, what do I get? I call it as y of t, x1 of t plus x2 of t it is. So I mark it as 0, 1 and 2. So 0 to 1, from 0 to 1 I don't have any signal here, it is 0, as good as 0. From 0 to 1 I have amplitude 1, I write. From 1 to 2 I have amplitude 1 here plus this triangular pulse is getting added. So hence it will be shifted by some DC level like you have observed in clamper. Okay, so this amplitude was 1 here, so when you shifted, 1 plus 1 becomes 2. So this is the added signal, composite signal. So these are the examples for some examples for operations performed on dependent variables. With this we are concluding lecture number 7. We'll see you in the very next class. Thank you.